It is. Okay. Okay. I can't help you if you won't listen to me. I am. I'm totally talking to you. It's just recording everything I say. So right now I heard me say, shh, I can't help you if you won't listen. And that's on the thing. That's going to be on the YouTube recording. Okay. So here's the deal. For the first ones, we're just reviewing. So the things that you have to know. We talked about this before. So 30s, 60s, 90s, okay, multiples of those, and then also 45s. The radian is just another name for the angle, okay? Those are just the names of the angles. But then with those, you should have associated coordinates, okay? So 45 was a little bit easier. The x and the y coordinate at that position were both root 2 over 2, okay? For 30 and then also for 60, I know that they use the numbers root 3 over 2 and 1/2. If you're confused which one is which, I usually think about where they are. So a 30 is like here around the circle, and then 60 is like up here. So a 30 is a long x with a short y. So longer x, shorter y. And a 60 is a shorter x with a longer y. So the other way around. Once you have that idea down, you have to remember that when they ask you for the sine of the angle, it's essentially the same thing as them asking you, what is the y coordinate when you're at this position? So when they say, what's the sine of 30 degrees, they say, okay, if you're at the 30-degree location and you know the coordinates at that location, what is the sine? Which one is the y coordinate? And so you would say 1/2. Okay? All right? So in part B, they're asking you for a tangent. How do you find tangent with respect to using the coordinates? Y over x. So you have to actually do some work. And so a lot of people memorize them. You can decide if that's what you want to do. And then you have to find where pi over 6 is. So usually you guys are more comfortable with degrees because it's something you're more familiar with than radians. But you should have memorized that pi over 6 is the same as 30 degrees. So this is basically asking us to calculate the tangent at 30 degrees. Okay? So I want to do the y divided by the x. So in this case, the y is 1/2. The x is root 3 over 2. So remember when you're doing that division, you're doing 1/2 divided by root 3 over 2, which means times by the reciprocal. So you get 1 over rad 3. And then when we write our final answer, we don't leave the radical in the denominator. So we multiply top and bottom by rad 3. So we get root 3 over 2. Guys, if you've been doing the work with tangents and cotangents, for example, every time you guys use a 45, how does the tangent work out when you're using a 45-degree angle? At every 45-degree angle, what type of number do you get when you calculate the tangent? Look at the 45s, okay? When you take the y and you divide it by the x, if they're the same thing, every time you get something to do with 1. So by default, I guess, I kind of know the tangent of anything that's a 45 will be 1 or -1, depending on if there's positives or negatives. Not because I tried to memorize it, but because if you've done enough practice with it, they always turn out that way. So if you've done enough practice with your 30s and 60s, we just did the 30-degree angle. So at every 30-degree angle, every time you divide the y by x, you're doing 1/2 divided by root 3 over 2. It's working out to be this, which ends up being root 3 over 3. Okay? At a 60, it's root 3 over 2 divided by 1/2. Okay, so think about what that looks like. Root 3 over 2 divided by 1/2. You'll just get rad 3. So what happens as you do more of these problems is you guys will get pretty familiar with the fact that when you see root 3 over 3 or rad 3, you know that those go with the tangents for 30s or 60s. So a lot of people will flat out memorize. Every time it's a 30, its tangent is root 3 over 3. Every time it's a 60, the tangent is rad 3. So that's one way you can do it. You guys know I'm not good at memorizing. So I don't always memorize it, but I know the two numbers. Like I know root 3 over 3 and rad 3 because that's how they work out. And I can tell when I go to start the problem pretty quickly how it's going to work out. When this one's on top, there's no need to rationalize the denominator, so I know I don't end up with the fraction, stuff like that. So you guys decide what's going to help you the most. If it's going to help you the most to flat out memorize that the tangent of 30 is root 3 over 3, then that's what you should do. Okay? And then you should memorize that. So decide how that's going to work. Okay? So is everybody okay with what it's asking us straightforward? When they give you the angle in degrees or radians, you find that spot. And then when they're asking you the cosine, they're asking you for the x coordinate at that spot. The sine is the y coordinate, and the tangent is the y divided by the x coordinate. Okay? Are we good with that? All right. So what are we going to be doing today? So today, we're going to use inverses. That's funny. That's not what it looks like on there. Okay, but this is, right? Okay, so right here, okay, let's use this one as an example because we just did this. You guys just found the sine of 30 and you got 1/2. Okay? Now we're going to be using inverses, which means they want to ask you guys a question the other way. You guys have done inverses before. Let me write on this previous page and remind you guys. When you guys wanted to solve something like this, okay, and you wanted to figure out the angle, and remember you had to get the angle out of the sine, you guys used the inverse sine, right? And you said, I'll find the angle by taking the inverse sine of 1/2. And basically, when you do the inverse, it's asking you, what's the angle that gave somebody the sine of 1/2? So instead of giving you the angle and asking you for the sine, they're giving you what the sine was, and they want you to figure out the angle. Okay? So when we look at the notation here, if somebody takes the sine of y, is y an angle, or is it a coordinate on your plane? If you can take the sine of y is an angle, okay? And the sine of the angle turns out to be a coordinate. Right? So when you write it in inverse notation, you would write it like this. Inverse sine, so remember the little -1 just means the inverse. Okay? But when you take the inverse, you know the coordinates, and your answer is the angle. Okay? So what used to be what you were taking the sine of, the angle, is now the answer when you're finding the inverse sine. Okay? So like when it says sine of 30 equals 1/2, the way that somebody would write that in inverse notation is they would say the inverse sine of 1/2 equals 30. Okay? So when you see the little inverse sign, know, oh, they're giving me the coordinate information, and I'm supposed to go find the angle. Okay, so the answer to the inverse is the angle measurement. Before that, we were being given the angle, and we were finding the coordinate. So like this one, we would say the inverse tangent of -4/3 equals x. They can write this a couple different ways. They might write it like this. They also use notation like this. Arc sine. These mean exactly the same thing. They are both saying to find the inverse, okay? And you can use it with any of the trig functions. So they could call this like arctan, okay? Is the same thing as that. So if you like one way and then you see the other way and your brain gets all frazzled, just rewrite the problem each time you see it if you don't like the arc or something like that. But those mean exactly the same thing, okay? So here's the problem, though. So go ahead and look at your unit circles, okay? So take them out if you don't have them because it's going to help us for a little bit. So take a look at your unit circle. So what this was saying, okay, the inverse sine of 1/2 is saying what angle has a sine of 1/2. So it's not telling you what angle to go to. It's telling you the sine. Was the sine the x or the y coordinate in your coordinates? When you're finding the sine, are you finding the x coordinate or the y coordinate? The y coordinate. So when they say inverse sine of 1/2, they're saying what angles have a y coordinate of 1/2? Go around your circle to all of the angles right now, okay? And tell me which ones do you see that have 1/2 in the y coordinate spot? So 30. And also 150, okay? 330 has -1/2 in the y coordinate spot, right? That's okay. Okay, so there becomes a problem with like, why is the answer 30? Because we look at our unit circle, right? And we see, yeah, at 30, the y coordinate is 1/2. So I get it. The inverse sine of 1/2 happens at 30. But we also saw that it also happens at 150, has 1/2 here. Okay? There's another angle I could think of. What about 390? 390 is really the same as what? 30. So will it also have an inverse sine of 1/2? Yeah, the inverse sine of 1/2 could be 390. So why is 30 the answer? And if in the calculator you type the inverse sine of 1/2, it will only give you 30. It will not list 30, 150, 390. How many could we list if we were going to list the entire list? Infinitely many, because we could keep adding 360, and we can not only list those 4, but we could just add more and more and more and more and keep listing them forever. And what if we went negative instead of positive and said it with a negative name? There's a whole nother group of them. So mathematicians had to kind of come up with a standard, like, you know what? I don't want everyone to give me the infinitely many answers that could happen here. Sometimes I do. There are reasons I want those. But in general, I want the one answer, and I want us to all talk about the same one. So in order to do that, they basically set up like an arbitrary standard. Like the people coming up with this said, okay, here's what we'll do by default. We'll list this as the answer. Okay, kind of like grammar rules and like rationalizing denominators. Like we do that because by tradition somebody set it up that way and said it's not appropriate to leave it the other way. Okay, so when they came up with trig, they said, oops, this is going to be a problem. I say 30, you say 390, you say 150. We're all technically right, but we're not going to be able to do the same calculations if we don't set up some standard of how we should do it. So they set up the standard. And so that's what you're going to write on your notes, except for this is totally not. Hold on. Pause. Sorry, there's two comments. All right, so what we're going to do right here, and you have this exact thing on your note guide, is you're just going to remind yourself which angles you're going to pick. So why does the calculator only pick 30? Well, it's kind of dumb, because when they set this up, that's how they made the rules, so to speak, okay? But if we want to calculate it right, we have to understand those rules. So when you calculate the inverse sine of something, think about the unit circle, okay? And think about the properties of the sine. In the first quadrant, if you calculate the sine of an angle in the first quadrant, so the y-coordinate at any of these points in the first quadrant, is it positive or negative? Positive. Okay. What about in the second quadrant? Y-coordinate, positive or negative? Positive still. Okay. Third quadrant, negative. Fourth quadrant, negative. So here's the thing. The reason the answer could be 30 or could be 150 is because those points have the same y-coordinate because they're both positive. So if I want us all to talk about the same one, I can't pick the first and the second quadrant because we'll have overlapping numbers because there's positive ones in one and also in the other. So they had to choose one quadrant that has all the positive stuff and one quadrant that has all the negative stuff. So they chose these two because they're like connected. So it was easier to pick. Okay. So basically, when you answer an inverse sine question, you give an answer that's an angle. The angle that you're going to pick by default, since there's multiple ones that could answer it, is going to be an angle from this area. And here's how they define it. They say you're picking an angle that's between here and here. I know that's kind of weird because we think of 0 being right here, right? So normally we'd say from 0 to 90 or 270 to 360, but mathematicians don't like breaking it up like that. They just want to write one continuous thing. What's another name for this angle instead of 270? What if I went this way around the circle? What would this angle be called? Negative 90. So the way they say is they say pick something from negative 90 to positive 90. Okay? Or from negative pi over 2 to positive pi over 2. Okay? So that's why when we say what's the inverse sine of 1/2? And we go, oh, well, it happens at 30, it happens at 150, and I could pick some other things. I pick the 30-degree angle because it's an angle measurement between negative 90 and 90.
So basically just positive x.
Yes. Mm-hmm. So what if we said, what's the inverse sine of negative 1/2? So think about what it's asking. Where is the angle that has a sine value that's negative 1/2? So use your circle if you have to, okay? So sine is the y-coordinate. Look around your circle. Which angles have a y-coordinate that's equal to negative 1/2? Good. So 210 and 330. Now, according to where they say we're going to pick from, which one are we going to use? 330, and then here's a little bit of a bummer. Can we call it 330? Does the number 330 fall between negative 90 and positive 90? No. So what should we call this instead of 330? Negative 30. Okay. So is that okay with what this is asking? How the inverse is just worded a little bit differently than the other things? So we don't use the same area for cosine and for sine. We do for sine and for tangent because when you look at the tangent, okay, the tangent would be positive here because you'd be doing a positive divided by a positive, so it would be positive. In the second quadrant, you would be doing a positive divided by a negative, so the tangent would be negative. In the third quadrant, you would be doing a negative divided by a negative, so this would be positive. And then here you'd be doing a negative divided by a positive, so it would be negative. So they can still pick these same ones and capture tangents that are both negative and positive by using the same thing from negative 90 to positive 90. So tangent, when you calculate this angle for the inverse tangent of x, it's going to follow the same rules as the sine. Okay? For this reason that you can get the negatives and the positives by doing that. So those two are going to be the same. Okay, so let's say I ask, what's the inverse tangent of 1? Now, this one's a little bit harder because tangent was made by dividing the y divided by the x. So what kind of angles, when you take the y and divide it by x, do you get 1 as an answer? When you're using the rad 2 over 2, rad 2 over 2. So what kind of angles does that happen at? 45s. So the answer to this is a 45. It's either 45 or negative 45 based on my rules. Okay? The tangent is positive up here and it's negative down here. So where is it equal to positive 1? At 45 degrees. Okay? Let's say I asked you guys the inverse tangent of negative rad 3. Okay? So you're going, okay, somewhere on the circle, the tangent turned out to be rad 3. What kind of angles are going to have a tangent calculation that turns out to be rad 3? At least narrow it down. Some either a 30 or a 60, right? And either you have memorized, like I said earlier, which one is which, or you do a little test to figure out which one turns out which way. When I do 1/2 divided by root 3 over 2, I get this. When I do root 3 over 2 divided by 1/2, I get this. This is what they're asking for in this problem, rad 3. So it had to be this y divided by this x. Okay? So which angles have 1/2 as an x and root 3 over 2 as a y? 60s, okay? And so either it's 60 or it's 300, which we're going to call negative 60 in this case. Which one would have the negative tangent? At 60 or at negative 60? Negative 60. Okay? So a new way of them asking you the information, but still using all the information on the unit circle. It's not like something else that we have to learn. We have to know all that information well enough to now answer the questions when they ask them to you the other way, okay, when they ask you with the inverse. So the cosine setup can't be exactly the same as these other two. Because if we look at what we looked at here, if we go to set up the cosine is the x-coordinate. So when you're in this first quadrant, is the cosine positive or negative? Positive, okay. In the second quadrant, x-coordinate, negative. In the third quadrant, negative. And in the fourth quadrant, positive. So they can't do the same negative 90 to 90 this time because you would only be getting positive cosine values and you'd never be able to solve a problem with a negative cosine value. So for the cosine, they choose to use the first two quadrants, basically numbers from 0 to 180. So when you're trying to figure out an angle, when you're using the inverse cosine, for that angle, you're going to pick values that are between 0 and 180. Or 0 and pi. So let's say I ask for the inverse cosine of negative root 3 over 2. So the minute you see root 3 over 2 in that problem, what should enter your head? What should that be related to? What kind of angles? 30s or 60s, right? You should at least be able to narrow it down to that. You at least want that connection. Numbers like 1/2 and root 3 over 2 are with 30s and 60s. Numbers like root 2 over 2 are with 45s. So the minute I see this, I'm thinking, okay, the answer is about some sort of 30 or 60 degree angle. Okay? So then I have to actually think, when is it that the x-coordinate is root 3 over 2? Is that at 30s or at 60s? Where the x-coordinate is root 3 over 2. So I wrote them up here. So that's happening at 30, okay? And I specifically want it to be negative root 3 over 2, okay? So there's a 30-degree angle here, and there's another 30-degree angle over here that's 150, okay? If I want the x-coordinate to be negative root 3 over 2, that's going to happen at this location specifically, okay? So that's the 150-degree location. And that's between 0 and 180, so that works. Okay? What if I asked you guys for the inverse cosine of 1/2? Okay, so 60 and 120 both have x-coordinates of 1/2, and then 120 has an x-coordinate of negative 1/2. Okay, so since this one's positive, we would choose the 60. So if you know your unit circle well and you understand that with this notation what the inverse is asking you, it's not going to be that much different than what you were doing before. The biggest deal is going to be remembering these things here. Okay? Now, there are times when you don't use this, but unless the problem specifically tells you, I want you to pick angles between and list something different, this is going to be our default. Okay? We're going to choose the angle like the calculator would choose, so to speak. Okay? And it would use these ideas. Okay, so let's see. You guys don't have to do this. We'll come back and do this. All right. So the other thing that could happen is you could see all of this stuff combined together in problems, okay? But it's just like order of operations. You just start at the innermost set of parentheses and you work your way out, okay? When you look at the two problems that are up there right now, which one has a number in it that you're like, okay, that's familiar. I could find something on the unit circle for that problem. Yeah, rad 2 over 2. So that should start looking familiar too. So let's do that one first, okay? So the first thing you're going to do is this calculation, right? Because it's kind of the innermost calculation, and then after that, we'll apply the other idea to it. Now, this calculation is an inverse calculation. What type of answer should I get if I'm answering a question about an inverse cosine? Should I get a coordinate or should I get an angle measurement? Angle. Okay, inverses give you angles. You guys only used inverse in your calculator when your answer was an angle. Okay, so this is asking you what angle has a cosine of root 2 over 2.